Cool. Well, thank you for joining. So this is a introductory session on Cluster API provider AWS, specifically targeted at new contributors. So we will be following the CNCF Code of Conduct. So just a reminder to be kind to each other. We'll also follow the usual rules for office hours, which basically means if you want to ask a question or say something, if you can use the raise hands feature in Zoom, that would be good. So we do have some slides just to give some background, and then we'll start the code walkthrough at the end. It would be good to make it interactive. So if you have questions as we go along, it's probably best to ask them there and then. Just so we can cover them off. So yeah, and we can adapt this depending on the questions or however people want to take it. And this will be, I guess, the first of a number of sessions. So this will be fairly high level, just to give, set that expectation up front, and then we can follow this up with specific sessions on certain areas of the code or testing or something like that. So let's get started. So we'll start with introductions. Sadef, did you want to go first?
Yeah, sure. Hi, everyone. I'm Sadef. I am working at VMware for the last 2 years, and I am a Kappa maintainer for about a year now. Yeah, I've been in the Cluster API domain for the last 2 years, mainly. So welcome all.
Cool. Cheers, Sadef. I'm Richard. I'm also a Kappa maintainer. The list of maintainers has shrunk over the last year or so. So there's only 2 of us currently. Something we want to change. I work at Weaveworks as principal engineer, so I do Kappa related stuff. A different provider other than the AWS provider. So yeah, so I do work in the Kappa world. So. So I thought it'd be good to start with, if anyone on the call actually just wants to introduce themselves and just say a bit about why they're here. Completely optional. Feel free to unmute yourself and say hi, but you don't have to.
I can start.
I'll go.
Okay, I go. So Fabrizio Pandini, I'm a Cluster API maintainer, and I'm here to catch up a little bit with Kappa. So thank you, Richard, and Sadef for organizing.
Hey everyone, this is Mike. I work on the EKS team at AWS, and I'm also here with Jay, Raphael, and Nick, also from EKS. So we are interested in getting more involved, have some ideas on how we can contribute.
Hello, I'm Clifford. I work at Weaveworks with Richard. So I'm customer facing. So I work as a CRE, and yeah, my interests are in all sorts of different Kappa providers, AWS among them. So nice to meet all of you.
Hello, this is Raphael. I'm engineering manager here at EKS AWS. Nice to meet you all.
Cool.
I continue. I'm Stefan, also a Kappa maintainer. Just interested in Kappa and see how it works and get some information here. So thank you very much for organizing this.
Hey, I'm Jay Pipes, engineer on Kubernetes team here at AWS. I focus mostly on AWS API integrations with Kubernetes and the AWS controllers for Kubernetes project. So a lot of code generation and declarative config management, GitOps stuff. So anyway, excited to learn about Kappa and how we can contribute.
Hello, I'm Chris. I work at Weaveworks. I'm also really psyched to be here. I want to learn about Kappa maintainer activity and contribution, and yeah, I'm specifically interested in the AWS work, so looking forward to it.
Cool. I think that's pretty much everyone, isn't it? Brilliant. Yeah, thank you for that. So put an agenda. So we're going to start with, what is Cluster API for those that don't know what it is. It's very high level. And, if you want to go more deep into that, Stefan has been running a number of sessions on the CAPI side, which I can highly recommend. Then we'll move on to what is Kappa at a high level, and walk through some of, I guess, the concepts and the resource kinds that are important. And then we'll move on to a high level code walkthrough. Just, what is the repo, what are the main, what are the important folders, etc. And then right at the end, we will discuss, what topics people would like to see in a following session. Cool. So we have a couple of CAPI maintainers on this session. So if I say anything that is not entirely correct or could be explained better, I would welcome interjection, which would be good. So from my side, Cluster API is built on the premise that cluster lifecycle management is difficult, and it has been difficult, or traditionally difficult. There's been lots of different ways to provision or create a cluster, depending on your target infrastructure. So you might have used Kubespray, COPS, pick your poison in that respect. Normally there wasn't a consistent way to provision and bootstrap and manage the life cycle of Kubernetes clusters across different infrastructure providers. And for me, when I first came to CAPI, this was the main selling point, having gone through a lot of pain with other provisioning mechanisms, and having to change them depending on the target infrastructure. And coming from Weaveworks, a core, I was really interested in the fact that it was declarative in nature. So I specify what I want my cluster to look like, as a declaration, like I would a normal workload that I was used to on Kubernetes. And I apply that declaration to a management cluster, and auto-magically out the back I get a Kubernetes cluster. Really handy for GitOps, but actually not working in an imperative way. It was really beneficial. So I personally really like that aspect. Over and above that, it brings higher order functionality to the provision and life cycle of those clusters. So things aren't, this is not an exhaustive list here, but there is a concept of cluster templating, and I mean there's two versions of this. There's the traditional what we call flavors of clusters, and then there's the more recent cluster class style classes of clusters. And that's really useful when you start to operate a large fleet of clusters, as we are. We're increasingly seeing more of that. And then there's automation around, the scaling and repairing and upgrades of the clusters that you've provisioned via CAPI. So to give an instance, so if I want to upgrade the EKS version, I'll change one field in the control plane declaration, and then Kappa will manage that version upgrade to the correct version, and there's a bit of interchange between CAPI and Kappa on that aspect. When working, specifically in AWS, but this applies to all CAPI providers. It will try to distribute the control plane nodes across failure domains, and failure domains can mean different things in different operating environments. But for Kappa, a failure domain is a availability zone. So it will try and automatically distribute those control planes across the availability zones for your cluster. And then there's things like machine health checks. So if there's a custom way to determine the healthiness of a machine, you can implement that, and it will automatically replace those unhealthy nodes. And this all happens automatically for you. So, some of these operational tasks that you would have to do manually previously, you don't have to do. And more recently, we started to see the introduction of managed control planes. Now, this isn't a separate concept in CAPI, but more of an implementation detail that managed Kubernetes services are appearing in CAPI now, and specifically in AWS and the Azure provider. And there's a lot more to it here, but that's just to give you an idea. So core to the whole of CAPI is this concept that there are interchangeable components. These are often referred to as providers, and there's different types of providers. When you get into it, there is an infrastructure provider, and as the name suggests, the idea with this is it provisions any infrastructure in the target operating environment that is required for the cluster. So specifically for AWS, this would be things like VPCs, subnets, security groups, etc., and machines. And machines to the point that they don't know about Kubernetes themselves, which takes us on to the next type of provider, which is a bootstrap provider. So the bootstrap provider essentially will create the user data, essentially, or the bootstrap that will then contain how to bootstrap Kubernetes on the infrastructure, on the machines that the infrastructure provider provides to you. So the core, the out of the box bootstrap provider is kubeadm based, but this can be pluggable. So there are other mechanisms. So we actually, when we come into this, when you'll see later on, the Kappa has its own bootstrap provider. Likewise, there are control plane providers as well. And this is where we start to see some differences between a kubeadm bootstrapped cluster, i.e. unmanaged. We often refer to it as unmanaged in Kappa, and a managed cluster, which would have the control plane being EKS in this instance. And the control plane it does map to the control plane or the control plane nodes in a Kubernetes cluster. That's its purpose. So if you're new to CAPI, a lot of the operations that you perform are done via a CLI called cluster cuttle, and this is where you perform the lifecycle management tasks. So that might be install providers into a new cluster, a new management cluster. Well, install the providers that then make it a management cluster. But it also might be moving the definitions of a cluster from an initial bootstrap cluster into a permanent management cluster. So they have this concept of pivoting into a management cluster. And there is ongoing work to implement an operator that will make the installation of the providers declarative. And this is really interesting when you start to think about GitOps, and I can manage the versions of the providers via GitOps. So that's ongoing work with the provider. CAPI as a project sits under SIG cluster lifecycle, and there are community calls or office hours calls every Wednesday, 6 p.m. GMT or 10 a.m. Pacific. So there's always good discussion on those. So it's definitely worthwhile going to those. And I sort of mentioned this earlier. If you're really interested in getting into the details of CAPI, then I would recommend that you watch the Let's Talk About series that Stefan has been organizing and running. The link is below there, and that's to a discussion that holds, and Fabrizio, sorry, that has a link to all of the sessions that have been run so far, and the planned ones, and a link to the recordings. So yeah, highly recommend it. And in fact, these sessions that we're going to run in Kappa are actually inspired by those. So yeah, I appreciate that, Stefan and Fabrizio. Of course, I mentioned that CAPI is designed around this concept that there are interchangeable components or providers. So what is a provider? So essentially, a provider is a number of things. It's a set of custom resources, and those custom resources will adhere to a contract, depending on the type of provider it is. And the contract basically means a certain set of fields that are in the spec or the status, and they will be used to communicate between the provider and CAPI. So that they are covered in the documentation for CAPI, and that documentation is actually, part of it is being rewritten as well. along with those custom resources, there's going to be a controller, essentially, that will reconcile that custom resource. And then what that reconciliation process does, it obviously depends on the type of provider you're implementing. So to give an example, we have something called the managed control plane provider, and that will essentially reconcile and create EKS control planes in AWS. Just to give an example. It also includes any of the Kubernetes resources, so any customization stuff, essentially, that will be used to deploy that controller manager into a management cluster. And then there's some conventions around metadata and repository layout that providers adhere to, so that they are discoverable and can be used with things like cluster cuttle in it, so it can find where those versions are and the releases are. So there are some conventions and expectations around that for that to work. So I actually borrowed these. I didn't create these diagrams myself. I borrowed these from a session that was run at KubeCon, but I think it's quite a nice representation of the providers and the resource kinds. So in these white boxes, essentially, are upstream CAPI definitions of resources. So there is the concept of a cluster that sits right at the top. And I should say up front, this diagram doesn't contain all of the resource kinds. It's just a subset of them. But essentially, everything starts with a cluster at the top. And a cluster can be made up of machines, or individual machines, or machines as part of machine deployment. So machine deployment is a set of machines. So you can say, I want 5 copies of this machine. Very similar to a deployment, that's the best way to think of it. And then I mentioned about these custom machine health checks. So that's the starting point. So then when we're talking about machines, we need to know how to bootstrap Kubernetes on those machines. So this is where a bootstrap provider comes in, and that's specified via bootstrap config or a bootstrap template in the case of where you're stamping out multiple replicas of a machine. So this is another extension point. Then we have to have infrastructure specific versions or twins or pairs of these. So if I want to create a cluster in AWS, I'm going to have an infrastructure version of the cluster or the infrastructure provider. Likewise with the machines, and these will hold the infrastructure specific things. So the AWS specific things that don't live, that are not generic and covered by upstream CAPI. So to give an example, on the CAPI cluster, I might have the pod CIDR range because that's generic across the cluster. Whereas on the infra cluster here, so I would have to put in things like the VPC or the region, because they are very specific to AWS. And then right at the bottom, I could fit it in on the slide very easily, is the concept of a control plane. These colors will become apparent. It's just so when we see the AWS versions of these overlaid, that will make sense. And the control plane is essentially will create a Kubernetes control plane, and that will be made up of a bootstrap configuration and nodes and machines, essentially. Cool. So I will pause there before we get on to what is Kappa, just in case there's any questions. There's a diagram later on that will be overlaying the Kappa specific resources onto this diagram. Cool. So what is Kappa? So first and foremost, it's a cluster API provider, and it is an infrastructure provider. I have put that it is a bootstrap and control plane provider as well, because historically it has been. And when I say separate providers, I mean this from a cluster cut-all point of view. So when I say install the providers into my management cluster, historically you had to specify the bootstrap and control plane separately. So there were separate AWS providers for those. More recently, we have combined those all into one provider. So from a usability point of view, when I do cluster cut-all in it, I can just do dash infrastructure AWS. So I don't have to specify the other ones. But from a code organization point of view, they are still very much separated within the repo, and we still think of them as separate providers when we talk about them in Kappa. And as you can imagine, this is specifically for running Kubernetes clusters in AWS. The name gives it away. But it will create all of the AWS infrastructure required to provision and run that Kubernetes cluster. It's opinionated in that respect out of the box. So it will create, if you don't specify VPCs or anything like that, it will create them in an opinionated way. If you don't like those opinions, you can create the infrastructure separately and reference those in the definitions and just reuse those the infrastructure. So you can bring your own infrastructure is the second point when we call that unmanaged infrastructure. Sometimes when we talk about that, essentially we support creating two types of cluster. So historically, Kappa only supported creating unmanaged clusters. So basically EC2 instances for all of the nodes, so control plane and worker nodes, and kubeadm bootstrapped to actually create the cluster. But more recently, we have added EKS support, so you can create an EKS-based cluster. So we have our office hours calls or community calls bi-weekly on a Monday. Again, these are at 6 p.m. GMT and 9 a.m. Pacific time. So it's an open agenda. So people add topics to the agenda ahead of time or as they join the meeting, and we follow that. If we have time at the end, we generally try and triage any new issues. And then we hold separate grooming sessions and milestone planning as well, but they generally don't happen in the bi-weekly calls. So as we mentioned right at the beginning, there's currently 2 maintainers, myself and Sadef, but we are actively trying to get more contributors, reviewers, and maintainers, because the numbers of maintainers has dropped more recently. So actually to get involved, the repo's there. We also have a Slack channel on the Kubernetes community Slack. So that's Cluster API AWS. And actually, when you first start in, we follow the usual practices. So we've labeled, good first issues and help wanted issues. So they're always a good starting point, but not limited to those. So if I go back to those diagrams, so what does that actually look like from a Kappa point of view? So we have AWS cluster, from a cluster and the infrastructure and control plane point of view, we have resource kinds AWS cluster, and that is specifically for unmanaged clusters. So purely EC2 for worker and control plane nodes. And then we have something called AWS Managed Control Plane. So AWS Managed Control Plane means EKS. And I've put a star against this one here because currently it acts as the CAPI cluster and the CAPI control plane. This will be changing, but currently it satisfies both roles and satisfies both contracts. And if you see that it is it's EKS. So those two types of clusters, you'll see that they use credentials. So when you provision a cluster, it is got to use some credentials to create the resources in AWS, and there are essentially three ways to specify those credentials. They can be global, for every single cluster that you create in that management cluster, or they can be specific, and you can use different types of principles, we call them. So if we step down to the machines, so we support machines and machine pools. So machine pools is still an experimental feature in CAPI. So for us, machine pools are autoscale groups, basically, or managed EKS managed node groups. So yeah, they basically go to autoscale groups. Then we also support just individual machines via the AWS machine, and that will just map to an EC2 instance, basically. And then the version of that is machine deployments, and then they will eventually map to AWS machines anyway. So that's how you can create a stamp out. Yep, go for it, Jay.
So how does machine pool relate to cluster autoscaler, if at all? Well, I mean, cluster autoscaler, in particular, the AWS provider inside of cluster autoscaler also uses ASGs, right? Is there sort of any relation between machine pool in CAPI and cluster autoscalers sort of concept of a node group?
No, there isn't. Not at the moment.
Okay.
So yeah, so this literally just machine pools in Kappa basically map to autoscale groups. They don't, not cluster autoscaler. Go for it, Fabrizio.
Yeah, maybe this can help. There is a proposal in the CAPI repository to basically add a machine behind the machine pool, like we have in machine deployment machines. And so when this proposal is out, one of the goals is that we can use the cluster autoscaler, because the cluster autoscaler look at machines. And so, yeah, there is work to make it possible, but it's not possible now.
Okay, cool. Thanks for the background on that, Fabrizio. There's also, I mean, I don't want to derail the conversation. There's also something called Carpenter and the AWS Fleet API from EC2, which is another, potential way of provisioning instances as a group, although it's not really a group, because with the Fleet API, it's not an ASG necessarily. It's a set of instances, right?
Yeah, that's a good comment. I think that, let me say, the main difference is that between machine pool and machine deployment is that machine pool has the ambition to leverage on the primitives that a cloud provider offers. And so if the machine pool by itself support autoscaling on something like that, we are not required to rely on external autoscaler. But basically, the API should support all this scenario.
Cool, yeah. We've had discussions in the past about Carpenter as well, specifically for Kappa. So it would be good to revisit those as well. So two last things on this diagram. You'll see something called EKS config. That is actually a bootstrap. So we have a bootstrap provider, and that is specifically for EKS and specifically for generating bootstrap.sh. So the calls to bootstrap.sh for that machine to join the cluster. So it maps directly to that. And then finally, we have this thing by itself on the left-hand side, AWS Fargate profile. So that's if you want to use, Fargate with EKS. So yeah, it sort of doesn't fit naturally anywhere in this diagram. So it's a bit lonely. Cool. So I thought I'll quickly whiz through a brief history of Kappa. So it's been going nearly 4 years now. So the first commit was in July 2018. Since then, there's been like 100 different contributors, which is good. So first release 0.1 was back in June 2019, before the pandemic. So then I guess I've just picked out some of the milestones since then. So 0.5 back in March 2020 was when V1 Alpha 3 was introduced. 0.6 was an interesting release. It was quite a big release for us, and that's when we added experimental support for EKS. And then a few releases later, in 0.65 in April 2021, we added multi-tenancy support. So prior to this, you had to provision all clusters with the same credentials, and those were the credentials of the controller that was running in the management cluster. After this, you could specify credentials per cluster. So it was a big change. And then in v0.7 in August, we GA'd EKS support when we also adopted v1 Alpha 4. And then more recently, we hit the v1.0 milestone, and that was coincided with v1 beta 1 of CAPI. And then more recently, February is the most recent release. Go for it, Jay.
How do you define GA?
Yeah. So I guess we follow the Kubernetes standards on that respect.
Okay. So are you? Do you have a different idea of what is supported by you as maintainers for GA things versus non-GA things?
So, I'm guessing Fabrizio has a good comment on this. So I have my view on it, but I'll let Fabrizio go first.
Okay.
Yeah, this is a tricky question in the open source world. So,
oh, I know. Trust me. I say it somewhat tongue in cheek because we have similar discussions around GA and preview in ACK.
Yeah, I can give you my take around this. So basically, in Kubernetes land, alpha, beta, GA means a certain set of guarantees on the public API of the project. Okay, and so more your project is in progress in the graduation, the longer you are expected to support an API. So it is a contract with the customer. Let me say with the user, the graduation. The second point of view is and this kind of let me say mechanic. GA deprecation 1 year is kind of mechanic, and the second part is more judgmental, and is up to the maintainers. Basically, they look at a feature, they know if it is completed or not, they get feedback from the user about adoption, and they decide to graduate the feature, saying that, okay, this is now stable, and people can make assumption on how it works or not. So there are two dimensions, API, which is, or CLI, which is kind of mechanical, and feature-wise.
Yeah, perfect. And I guess from a practical point of view, for us, when it was experimental, you had to explicitly enable EKS support by passing in a feature flag. When it went GA, it was enabled by default, and you had to explicitly opt out. There are still features that we didn't consider as being sufficiently used and sufficiently stable, such as FileGate support and the machine pools. And that was, machine pools are still experimental in CAPI, but we also felt in our own implementation they were not as used as the other machine types. But yeah, cool. Thanks, Fabrizio. Right, I was just going to do a quick whirlwind through some of the stuff before pass through to the start the code walkthrough. So we currently only support two API versions. Sorry, it was 3. Initially, I removed the third one this morning. So that's v1 beta 1 and v1 alpha 4. So I mentioned this before that, you know, experimental features, and we can cover what that actually means. Experimental means have to be enabled by feature flags, and there is a pattern that we follow that's quite common across all of the providers. Pretty much everything is in Go. You know, there's a whole bunch of crazy makefile stuff as well, obviously, but yeah, predominantly Go, and it follows the, you know, queue builder controller runtime pattern for the controllers and the project in general. So this is for, you know, how we write and specify the API types, the controllers, but also we use a whole bunch of the code generation tools as well. So there'll be a bunch of stuff around, you know, doing that auto generation of the code. So there are two main areas to the code. I guess there is the provider's side. I'm going to start with that. So that is the stuff that does, you know, runs in the management cluster, does all the provisioning, you know, the controllers essentially. And that uses the AWS SDK for Go, V1. We'll specifically call that out. And then we have a secondary part, which is an administration utility called Cluster AWS ADM. So this is a CLI, and you use this to perform certain operations. The main operation is sort of a one-time setup task per account, AWS account, and that basically creates like the AWS resources that are needed for Kappa to run. This actually uses CloudFormation, so we have a CloudFormation stack. Go for it, Jay.
Besides the IAM resources, what else is created by Cluster AWS ADM?
It's pretty much all IAM stuff. It hasn't. Well, I say that. Sorry. So, the one aspect of Cluster ADM is creation of those resources, but it does other stuff. So it encodes credentials as well. So given you know, your key and your secret, it will encode those in the correct format that Kappa understands for runtime. So you can embed those, and it does some other querying stuff like, you know, list me the EKS add-ons that are available for this cluster. But pretty much it's all
as far as like the resources that are created, the AWS resources that are created by Cluster AWS ADM, it's really just the IAM roles.
Yeah. We do create, you know, so it's roles, policies, groups. We create a group as well, and optionally we create a user as well. But you know, there's a bunch of stuff in there that you can turn on and off. But yeah, it's all IAM stuff.
I'm curious why you're using CloudFormation for that, but AWS SDK Go V1 for the other stuff. Was there a particular reasoning behind that, or just like that's how it was originally written? Or
in all honesty, I don't. It was before my time, but I suspect it was just the way it was written at the time, and we've never revisited it to make it consistent across both. And we should. Right.
Thanks, Richard.
That's right.
No, just saying thanks.
Cool. So I think this is the last slide actually for me talking. So there's a bunch of tests in the repo. So you'll see normal unit tests. They use standard Go tests, so nothing special there. There's an end-to-end test. Well, there's a number of end-to-end test suites. We use Jinko for that. There's separate suites for the unmanaged side of the provider, managed side of the provider, and performance. So you can run those tests locally via make targets, but they are also run via Prowl. So you can request them to be run, and they will also be run periodically, automatically every night as well. One thing to note, if you ever do some work with the end-to-end tests, they take a very, very long time and will suck, you know, a large portion of your life away, and can be slightly brittle. So I mentioned, I don't know if I mentioned this, so we do issue triage and release planning periodically. And for actual development purposes, or we'll cover this probably more in detail, more in depth later. So you obviously need an AWS account to get started because you need to provision stuff. And Tilt is heavily used. So if, you know, in the development process, and it really is a time saver. especially for debugging and just getting up to, getting it up and running. So I think that's enough from me talking. So I think we can probably start the code walkthrough. So Def.
Yeah, this was a great summary. Thanks, Richard. Yeah, so for the next 10 minutes, I will try to show you a few things that will help you get started with your initial contributions. So feel free to stop and ask questions along the way. You don't need to wait until the end. So let me share my screen. Can you grant me access?
Cool, that should work now.
Okay. Yeah, so I want to start by showing you an example cluster template. As Richard mentioned, we are supporting both managed clusters, which has EKS control plane, and unmanaged clusters, where a cluster API is managing the control plane. So the first cluster template I'm showing is what we call unmanaged cluster API managed control plane. So this is our cluster resource, which has some high-level common fields like pod-siders, service-siders that may be common across all infrastructure providers. And it has a reference to the infrastructure cluster that it is gonna use, which for Kappa, it is AWS cluster. And as I mentioned, the control plane is managed by cluster API for the unmanaged clusters. And for us, it is KubeADM control plane. So when we move to the AWS cluster that the cluster depends on, we have a couple of details, detailed settings regarding our infrastructure. So we can, for the clusters that don't have internet access, we allow creating a bastion node that can be used basically as a jump host to reach your internet restricted cluster. And currently we are supporting classic only classic load balancer. Network load balancer support is on the way. And we are supporting both internal and internet facing schemes in the load balancers. Then in terms of networking resources, we both support bring your own network infrastructure like VPC, subnets. You can create your own resources and just provide them here in these fields. Or we support a default topology in Kappa, where you just specify few like how many availability zones you want to use, and we go ahead and create the VPC and subnets for you. Just to give you a little bit idea, what we are doing in our default topology is that we are creating 2 subnets per availability zone, one private, one public subnet, and we create internet gateway per VPC and net gateways per availability zone for high availability. And yeah, all the nodes are going to the private subnet. So let me show you how let me show you the resources that we are creating quickly. For example, in the cluster template I applied, I have 2 availability zones. So Kappa created a single VPC. Under that VPC, we have 4 subnets, 2 subnets, private, public per availability zone, US West 1B and US West 1A. And we Kappa created net gateways per availability zone. Also, we have internet gateways. So if you go and check the route table of the public subnet, it is pointing to internet gateway. And if you check private subnets, it's pointing to net gateways. And if we go to the EC2 console, this is a load balancer that is created for API server, which is being used by the management cluster to reach to workload clusters. So right now, I only have a single control plane node in my cluster, and this is attached here. We are also supporting bring your own security groups, but if security groups are not provided, we are auto-creating them. Yeah, so in terms of security groups, so for example, for the control plane nodes, we are allowing bunch of inbound traffic depending on the, for example, CNI that you are using. You can customize those. Right now, I am having appropriate rules for Calico, for example. And we open the port for Kube API server port. SCD port is also open. And yeah, if you check the load balancer, we open the port for, these are changeable. These ports are changeable, not the internal port, but right now, our load balancer is forwarding 6443 to local API server port 6443. So this load balancer port is changeable, adjustable right now. So when we move to the instances that's created, so let me go back to the cluster template and move on. So this is the KubeADM control plane, which is responsible for the creation of control plane nodes. We provide a few things here. An AWS machine template, which will have information about what kind of EC2 instance we want to bring up for the control plane nodes, and KubeADM config specification. So this will include all the arguments that's needed for the KubeADM to init, join, and general like arguments for the general API server and controller managers. And if we move to AWS machine template, as I said, for example, in this case, we want to use this instance type. Here, we can also specify AMI ID, which AMI we want to use. I will come to that how we are. So if we don't provide an AMI ID, we fall back to the default created AMIs that is managed by Kappa maintainers. We regularly create AMIs for each new Kubernetes version. And if we move to the machine deployment, these are for the worker nodes. Again, we specify the KubeADM config template, what kind of, based on whatever fields we wanna customize, and an AWS machine template for the machine deployment as well. For this example, I only have a single worker node with a single control plane node. So these are here created. Yeah, so yeah, let me also briefly show that using cluster AWS ADM tool, we can also list the resources that is created by Kappa. So I'm just providing the like cluster name, and all the resources can be seen here. So yeah, let me go over the code, our repository structure a little bit. Yeah, we have our regular version APIs here with all the conversions, etc. And EKS Bootstrap provider is under Bootstrap directory. This cluster AWS ADM is under CMD. We are using Cobra library for this cluster AWS ADM utility tool. And yeah, using this cluster AWS ADM, for example, we can also list the AMIs that are available, published by us. These are just reference AMIs. For example, you can see the AMI ID that we published. You can also see those AMIs in our Cluster API AWS book. Here, all the AMIs are here. Also, you can go over how to create custom AMIs. We are using image builder tool to create our AMIs. So if you are interested in creating your own custom AMIs. So let me stop here to check if there are any questions. Jay, go ahead.
Yeah, for the AMIs, how do you manage the software supply chain and attestation of those images? Are you said you're using the what was the tool, the image builder?
Image builder, yeah.
Are they published on where they end up being published?
So you mean the AMIs we built? So
yes.
right now they are being published in a VMware account. We are in the process of moving them to CNCF AWS account. Right now they are all under VMware, actually.
Okay, are they just published like in S3 buckets or like to an image registry or sorry, repository somewhere, or just
like regular AMI images under the images that is public under the VMware account.
Okay, gotcha. All right. Thanks.
Yeah, so this image builder is basically using some Ansible scripts to install what is necessary to bring up a Kubernetes cluster, kubectl, kubeAPI server. Everything is automatically installed when you build your images using image builder cluster API, Ansibles. And let me go back to the repository. So yeah, so in the config package, we have all the manifests that we need, including CRDs, deployments that we need for Kappa controllers. And we use Customize to build them. And at the end, we have a single huge infrastructure component CMOs that we publish with each release. You can see in the basically, if we go to the releases, yeah. So we have a bunch of cluster templates as an example, and then a cluster AWS ADM binaries, and this infrastructure components include all the necessary CRDs, webhooks, deployments necessary to install Kappa controllers. Yeah, and our main controllers are under the controllers package, AWS cluster and AWS machine. And then we have a control. Go ahead, Jay. Did you?
Yeah, Sidef, I'm sorry, I have a hard stop at the top of the hour, but I did want to ask one question of you and Richard and Stefan. what are the top areas that we can help with? Like what are your biggest pain points as maintainers, and how can we help step in and basically help the most effectively that we can?
Oh, yeah, it's quite a big topic.
Well, yeah, I know, and we only got a few minutes left, and I apologize for that.
Yeah, so I know Mike's mentioned in the chat window about you know, ACK. So we have a whole bunch of code where we called it AWS SDK. We wrap it via services, services pattern.
Yeah.
But I guess that's all custom code. It's, it would be great to offload that to ACK is an example. There were discussions around crossplane, things like that, but ACK is probably a better fit considering this is the Amazon provider.
What about things like contributions around CI and end-to-end testing and that kind of thing? I mean, I know Nick's built up a bunch of experience using or building out the EKS controller in ACK and end-to-end tests, and I'm sure Nick sympathizes with the long end-to-end test times. But yeah, I mean, I'm just looking for big ticket items and areas that the team here can get involved and make a difference.
So the end-to-end tests, especially on the EKS side, really need some love. It's very much a single happy path test.
Mm-hmm.
We do try to exercise some of the different operations you can perform, but it's very basic at the moment, in honesty. So yeah, if we could get better end-to-end testing there to give us that confidence, that would be fantastic.
Cool. All right, like I said, unfortunately I have to hop off. This has been really, really useful and super helpful. Thank you so much, Richard and Sedef. I will see you on Kappa calls.
Yeah, brilliant.
Thank you so much.
Thank you all.
This was great. I think the other topic that I had that I didn't bring up, which is like a huge one, is it feels like the managed provider was kind of like an afterthought in CAPI, not specific to Kappa, just like not necessarily designed for like you mentioned at the beginning, it's working as two different things. And so I was curious to hear like thoughts on the evolution of where that might go. But I can come to the call next week if we want to discuss that.
I see Fabrizio's got his hands up, so go for it, Fabrizio.
Yeah, I think that this question comes really timely. Basically, it is starting. We had a meeting yesterday or the day before with regards to this topic, and the scope was a little bit broader. So how to make manage a provider first-class citizen in CAPI, and there are two sides of the same coin. So cluster APIs as abstraction for the user should more or less looks the same for the no matter of which kind of infrastructure are you using. So we should not put on the end user the burden to understand the difficulty. So there is a huge work in simplifying I don't know, user experience. I don't know if you are aware of cluster class that try to move all the templates that Sedef explained to us, and thank you. It is a lot. They are really improved since the last time that I look at the Kappa, and basically to move this template in charge to, I don't know, your product manager, the person that sells you the Kubernetes distribution, or your Kubernetes admin. So to expose on the user only minimal details that more or less should be the same across all the infrastructure. So one side of the coin is to make CAPI look the same across every type of infrastructure. The other side of the coin is to make the life of the provider implementers trying to fit into this model, managed provider, simpler than now. So we met on Tuesday. The decision is that let's rally on a document to sort this out.
Cool. Okay. Yeah. So a lot of good stuff going on. Yeah, I think at least myself, Jay, maybe others will start coming to more meetings here and get more involved in these discussions.
Cool. And Mike, I put another suggestion in there as well. We've had tickets open for bottle rocket support for ages as well. And people keep asking for that as well. So that's potentially another area as well.
Okay. Yeah, this one I'll bring up with the Bottle Rocket team because they're super involved in open source. Bottle Rocket is open source. This might be something they want to take up.
Cool.
All right. This was super helpful. Thanks all.
Brilliant. Thanks for coming, everyone. And we'll follow up in the channel.
Perfect.
Thanks.
Appreciate it. Thanks, guys.
Take care. Bye.
Cheers, everybody.